Now look at this fancy granite kitchen countertop. This one can also be available on the moon. I mean, there's no production whatsoever as of now, but there's enough raw materials for the kitchen of your dreams. And by the way, granite on the moon can even prove this dark horse had plenty of water at some point. So it all started when scientists found this weird blob of heat on the far side of the moon. It's all because of a massive chunk of granite that's buried underground. Apparently, granite is pretty rare outside of Earth, so this is a big deal. According to the researchers, there's this old volcano on the moon that hasn't erupted in like 3.5 billion years. But it turns out it's still giving off some serious radiation. The scientists used a fancy new method with microwaves to measure the temperature below the moon's surface. They found this area that's about 31 miles across, where it's like 18 degrees warmer than the rest of the place. And it's right under a spot that collapsed and is full of silicon. It's not as thriving as Silicon Valley back on Earth, it's just a volcanic crater, but without all the lava spewing out. The scientists even compared it to those granite rocks you see in Yosemite, like El Capitan and Half Dome. You know, those giant rocks that look super majestic? Well, apparently, they're made of the same stuff. Researchers claim that granite is super common on Earth, but not anywhere else in our solar system. So, this could change everything we know about other rocky planets. Right, now we know there's granite on the moon, but why is that important to us? So, you know how granite forms on Earth? It's all thanks to water and plate tectonics teaming up to create these huge blobs of melted rock beneath the surface. But guess what? The moon doesn't have any of that action going on, which makes granite super rare up there. But this discovery could give us some clues about what the moon was like back in the day when it had volcanic activity. Without water, making granite becomes a real challenge. But somehow, someway, they found granite on the moon. No water, no plate tectonics, but still, we got granite. So what does that mean? Did the moon have water in this one spot? Or was it just ridiculously hot? I guess we'll need to give a tad more time for the scientists to figure it out. The water on the moon is an issue, though. Duh. As of now, the moon is bigger than the Sahara Desert, but somehow 100 times drier. Astronomers have been debating for ages whether there's any water on this celestial neighbor of ours. But in 2020, NASA's SOFIA mission finally confirmed that there is indeed water on the sunlit part of the lunar surface. Turns out those grains of lunar dust have little molecules of H2O hanging out on them. Back in 1645, when people first started gazing at the moon, they were fascinated by these dark spots all over its surface. Dutch astronomer Michael van Lengren even made a map and called these spots Maria, which means seas in Latin. Sorry, Michael, they're just actually plains of basalt from ancient volcanic eruptions, but we still use the term Maria today. In 1892, an American astronomer named William Pickering discovered that the moon has practically no atmosphere. No clouds, no atmosphere, no chance for water to stick around. So, scientists started thinking that the moon was as dry as a desert. But then, in the 1960s, a theoretical physicist named Kenneth Watson came along with an idea. He suggested that water ice could actually exist in the shadowy craters of the moon that never see sunlight. These areas are called permanently shadowed regions. It was a mind-blowing concept at the time. The Apollo missions from 1969 to 1972 finally gave us the chance to look for water on the moon up close and personal. But when the astronauts brought back soil samples, there was no sign of water. So everyone went back to thinking the moon was bone dry. However, in 1994, NASA's Clementine mission suggested that there might be ice in these shadowed craters after all. And in 1998, the Lunar Prospector mission found evidence of hydrogen concentrations in the permanently shadowed areas. This was a strong indication of water ice at the lunar poles. The images weren't super clear, but it was still an exciting discovery. And finally, in 2008, scientists decided to take another look at those Apollo samples. They revisited the old data and found some hints that there might be water after all. It was like finding buried treasure in your own backyard. As you can see, the moon is a pretty promising destination. It even has enough stuff to produce your food supplements – calcium, magnesium, you name it. Just kidding, it's not the best idea to munch on them to boost your diet. But there are a bunch of other applications they can be used for. Calcium is like the fourth most popular element hanging out in the lunar highlands. But here's the cool part. Pure calcium metal is actually super flexible and can conduct electricity like a boss when there's no oxygen around. Who knew, right? Anorthite is a rare gem here on Earth, but up on the moon, it's partly central for calcium. It can even help make those groovy silicon-based solar cells. To make them, you need some lunar silicon, iron, titanium oxide, and of course, our buddy calcium and aluminum. It's like a recipe for solar success up there in space. The moon even has precious metals like gold. In 2009, NASA was on a lunar mission and they found some gold in the lunar soil. They had a spacecraft right behind the rocket, equipped with a fancy spectrometer. Its job was to study all the debris that got released when the rocket crashed. And they found all sorts of chemicals, like carbon monoxide, carbon dioxide, ammonia, sodium, hydrogen, and even a little bit of mercury, gold, and silver. Hey, vampires beware. Now I know it's been quite a while since then, like 14 years to be exact, but measuring how much gold is actually there has been a real challenge. You see, it's hiding deep beneath the lunar regolith, making it tricky to get an accurate count. Yeah, metals are fun and lunar water may have existed, but what about food? Good news, everyone! Scientists are saying that plants can actually grow on the moon, but don't expect a luscious orchard. It'll be more like a moderate garden with just a couple of beds. Here's the scoop. A while back, those awesome Apollo astronauts collected samples of lunar surface material called regolith and brought them back to Earth. Fast forward 50 years, and NASA decided to use 3 of those samples to try growing plants for the very first time. They used dirt from under the lunar rover bumper to grow these plants. The team added water and seeds to the samples, giving each plant a gram of regolith. Then they placed them in a clean room and added nutrient solutions every day. And they succeeded. During that challenge, the brilliant minds dealt with small plants like mustard greens in the nutrient-poor lunar soil. Yeah, we'll have to export olive oil from Earth to dress it. So, plants can indeed grow in the moon's soil. However, they won't be as strong and healthy as the ones grown on good old Earth soil, or even the ones in the control group grown in a lunar simulant made of volcanic ash. But hey, it's just a start. We're still to find out if our dear moon is hiding more treasures. You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours. Jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters. that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where earthquakes occur. No, scientists have recorded quakes, tremors, vibrations, and shakes in other regions of our solar system too. Let's take Mercury, for example. A few years ago, scientists discovered that this planet was shrinking, and that's why it seems to be so tectonically active. Or Venus. This world is a tectonic puzzle for experts. At the moment, Venus has no tectonic plates, and it might have never had them. But its surface has folds and faults and looks as if it could have tectonic plates. On the other hand, these features might have appeared because of other processes, for example, volcanic activity. But even though we haven't observed any Venus quakes, scientists believe they could detect them since their vibration seems to ripple through the thick atmosphere of the planet. Now, Mars. We know for sure that this planet is seismically active. NASA's lander placed a seismometer on the surface of the red planet, and in 2019, it managed to measure its first Mars quake. After that, the lander continued to record quakes, but they were so weak that if they happened on our planet, they'd be completely covered by the background noise of Earth's oceans. But a space body doesn't have to be a full-fledged planet to have active tectonics. Let's take Pluto. This dwarf planet is geologically active at the moment. In 2014, NASA's New Horizons spacecraft was flying through the Pluto system when it recorded complex geological features on this dwarf planet. Scientists concluded that Pluto might have quakes, or should I call them Pluto quakes, when its liquid water ocean freezes and thaws beneath the dwarf planet's icy crust. Jupiter's moons, Europa and Io, as well as Saturn's moons, Titan and Enceladus, are also geologically active despite their small size. Their features range from volcanoes and water plumes to potential subsurface oceans. Now, I bet you don't know these cool facts about earthquakes that occur on our planet. There's one place on Earth where a whopping 90% of all earthquakes occur. It's called the Ring of Fire, and it stretches around the Pacific Ocean from New Zealand all the way to South America. Looks to me more like a horseshoe. Anyway, experts claim that these countless earthquakes are caused by the abundance of volcanoes in that region and the constant movement of the tectonic plates. Around 500,000 earthquakes happen on Earth every year, but many of them occur very, very deep in the Earth's crust, and only special equipment can detect them. We feel around 20% of earthquakes, and only 100 of them can cause damage. The largest recorded earthquake occurred in Chile in May 1960. It was a magnitude 9.5 on the Richter scale. It was truly devastating. During that earthquake, seismographs detected and recorded seismic waves that traveled all over the world. They shook the planet for many days. As for the most powerful earthquake that occurred in the U.S., it was 9.2 and happened in Alaska. By the way, Alaska, along with California, is the most earthquake-prone state in the U.S. and one of the most seismically active regions in the world. A magnitude 7 earthquake occurs there almost every year. A mega-earthquake can actually shorten the length of a day for the entire planet. NASA claims that really large earthquakes can shift our planet's axis and, thus, change the duration of a day. Now, of course, you won't notice it since this change is measured in microseconds, and 1 microsecond is 1/1,000,000th of a second. Scientists think that the 9.1 Sumatra earthquake, which occurred in 2004, shortened the day by 6.8 microseconds. Now, not even the best specialists can predict an earthquake. That's mostly because the mechanisms that trigger earthquakes are extremely deep underground. But these days, people have learned how to figure out a more precise time frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs.
People haven't set foot on the moon in several decades, but the situation is going to change soon. NASA's Artemis program is going to send a few missions to Earth's natural satellite. The first astronauts might step on the surface of the moon already in 2025, as part of Artemis 3, if the current schedule holds, that is. And then the next stage will start, and it will be an even more ambitious project than sending humans to the moon again. NASA wants to construct a base camp at our satellite's south pole. Such an outpost will help the Artemis mission to break the previous record for the longest stay on the moon. So far, it's 74 hours, 59 minutes, and 38 seconds. Plus, such a camp can serve as a jumping-off point for missions setting off for deep space. According to NASA, at first it's going to be a small camp, accommodating missions for a week or two. But soon, it'll grow in size and complexity and will be able to sustain crews for a couple of months at a time. There might also be an open-top rover similar to the one used in the Apollo missions and an RV. These options can provide mobility for astronauts while they live and work at the camp. With each new trip, the level of comfort of space explorers will increase. Specialists are now developing the technologies that will help people to work more easily on the moon, far away from home. There's also hope that building such a camp can help us prepare for an even more challenging step: human exploration of Mars. For the camp to function properly, it's very important to be able to find and extract resources from the satellite's rocks and dust. These resources can include water ice, metals, oxygen, and even some building materials. It'll help to lighten the load with supplies delivered to the moon. It can also potentially allow astronauts to remain there for longer periods of time. Now, why the lunar South Pole? There are 2 very important reasons. First, building the base camp there will allow astronauts to have periods of continuous light from the sun. The moon is tilted in such a way that its south pole experiences up to 2 months of continuous light every year, when the sun is circling above the horizon all the time. And all this abundant sunlight can provide the camp with a lot of solar power. At the moment, NASA is trying to design a solar array that could stay more than 30 feet in the air. This way, it'll be able to make the most of the available sunlight. The second reason for choosing this location is deep craters that have been shrouded in darkness for billions of years, also because of the moon's peculiar tilt. Some of these craters haven't seen sunlight since the time of their formation. They're also known as permanently shadowed regions, and that's where scientists have found evidence of water ice. If we manage to access this frozen water and it turns out there's a lot of it there, it'll be hugely valuable for the inhabitants of the base camp. Plus, it might supply flights back to Earth, or further on to Mars. We don't know yet whether there's a lot of water in that region or whether it's free of contaminants, but NASA is going to find out. One of the ways to do it is to use Viper. This mobile robot is likely to arrive at the lunar South Pole in 2024. The Lunar Terrain Vehicle, or LTV for short, is scheduled to arrive on a mission in 2025. Astronauts will be able to operate it remotely, and it's likely to be able to avoid such hazards as rocks and craters on its own. Astronauts will then explore their surroundings either from the safety of the lander on earlier missions or later on from the base camp itself. Plus, NASA will use the LTV to conduct scientific or mission-related work even during periods of time when there will be no humans on the moon. The vehicle will play a crucial role in searching for water ice and other resources. But even though the LTV's remote-controlled capabilities are quite innovative, its design isn't going to change much. It'll look almost like the rovers that have come before it. If astronauts decide to drive the vehicle with its top open, they will have to put on their spacesuits, and that's not very comfortable. Donning such a suit can easily take hours. Plus, the duration of missions always depends on how much oxygen each astronaut's spacesuit has left. That's where NASA's RV-like concept, known as the Habitable Mobility Platform, comes into play. If this project succeeds, the RV will have a pressurized interior and life support systems, meaning passengers will be able to have a ride without their spacesuits on. This will definitely make life easier for astronauts. The final design of the vehicle isn't ready yet, but the main goal is to allow several people to live and work inside the vehicle for up to 2 weeks. Now let's have a look at what the future lunar cabin might look like. Its design hasn't been finalized either, but NASA is looking at modular and inflatable structures. It may help to create larger spaces for crews to live in. Plus, such kinds of structures are more compact and lightweight, so it will be easier to transport them to the moon. But there's one more intriguing possibility. How about a large-scale 3D printer that will use lunar soil and rock as its raw material? Such a machine might be able to produce bricks and other shapes, assembling dwellings from scratch. A prototype 3D printer is now building a test structure in Houston. Also, the first towns on the moon could probably be built in craters. They might be covered with protective materials like plastic, reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it can make it easier for astronauts to walk and even run on the moon's surface, it's not so great in the long run. That's why inside the lunar base, there might be an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1 to 5% of mineral density per month. A geologist from the University of Notre Dame, who's been studying samples of lunar soil, says that rocks or dust may have a key role in protecting astronauts from radiation coming from solar flares and cosmic rays. On Earth, the planet's atmosphere and its magnetic field filter out most of this harmful radiation. But the moon doesn't have the same shield because there's no atmosphere like on our planet there. The very weak one that our natural satellite has is made up of some unusual gases that haven't been found in the atmosphere of Earth, Mars, or Venus. That's why people working there will need extra protection. The experts say that up to 6 feet of lunar material might be needed to shield astronauts from the radiation. But besides building materials and water, there's another crucial resource on the moon, and it's oxygen. NASA hopes to start extracting this gas from moon rocks. They also hope to find metals like aluminum. This could allow astronauts to live off the land, and the base would become much more self-sufficient than expected. It could turn into a resupply station for spaceships heading for Mars. But a colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. Lunar camps are much easier to build and maintain. There will likely be direct spaceship routes connecting the satellite with Earth, and people will need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon will be growing, developing, and changing non-stop.